Assalamualaikum warahmatullahi wabarakatuh. Okay, now let's begin with lecture 4. Okay, now today we have to discuss various just you should know the idea. You must have studied this all in signals and systems, but I thought it's better to clarify first, help you clarify with the things so that we can so that there is no problem in unit second. Fine. Okay, so let's begin with various discrete time signals. So you have energy signals, like you have power signals, you have periodic signals, aperiodic signals, all you have studied, I hope. You have even signals, odd signals, multi-channel, multi-dimensional, deterministic, and random signals that all have been discussed. Okay, what is the energy signal? The energy of the signal, see, when the energy of the discrete time signal xn is denoted by E and is given by this thing, summation n is equal to minus infinity modulus of xn square. So the signal xn is called energy signal if its energy is finite. That is, your E should lie between 0 to infinity. Fine. So the energy of the signal is basically equal to what? It's equal to the summation of magnitude of the squared value of the xn. Fine. Now the summation is carried out what? Over all the sample values of xn. Fine. The signal xn is called the energy signal. So it should be if its energy is finite. Fine. Similarly, you have the power signal. So the power signal is done by this, and it's given by this mathematical interpretation, mathematical formula, right? So the signal is called power signal. If this power is finite, so xn is this, and then how power is given? Power is given by, if in exam it comes, just don't write a signal is power is finite. You have to also write how power is calculated, how you find out the power, like you find out the energy. So energy should be finite, it's a finite signal. Power should be finite, it's a power signal. Fine. Right. Then see, energy signal, this is the power signal. Again, these are the formulas that are used. This is for the continuous, I guess, and this is for the discrete. Okay, so a signal is said to be periodic if it satisfies this thing. What is this n? It's the period of the signal. Fine. So if xn plus you add some period, you will again get the xn for all values of n. Fine. It's a period. Otherwise, it's aperiodic or non-periodic. Let me show you an example. See, this signal it repeats after t intervals, right? So t is the period of this signal, right? Because it's repeating after t intervals. So this is a periodic signal. Like, can you similarly think of what is an aperiodic signal? What will be the example of an exponential signal? Yeah, right. So this is an exponential. It's not repeating after some amount of time. Is it repeating? See, it's decreasing and then it decays. Whereas your periodic signal, it repeats here, and if it repeats after suppose 2 seconds, so 2 is the period of the signal. 2 is the, what is this 2? The capital N is equal to, so I have a signal which repeats after, in example I have given t, but and it's a continuous signal. So if you have a discrete signal that is repeating after 2 seconds, so this n will be equal to 2. So xn plus 2 should be equal to again your original signal. So that means after 2 seconds, it's just the explanation of this is that after 2 seconds it's repeating itself. That is the periodic signal. Non-periodic signal I have explained. Okay. So now you have the even and odd signals. They are also called as the symmetric and anti-symmetric signals. Fine. A signal xn is said to be even or symmetric if it satisfies this condition, otherwise this condition. What do I mean by this? See, this is an even signal. Why do I say? See, here it is x of minus 1. It is equal to x of 1. Similarly, x of minus 2 is equal to x of plus 2. this is the condition for even signal. See, x of n should be equal to x of minus 1, like x of 1 should be equal to x of minus 1. Similarly, x of 2 should be equal to x of minus 2. But here in odd you have the opposite, they have opposite values. Here you have, they have same value. See, x of 1, what is it having value? Suppose this stick is representing one value. See, x of 1 is having one value. X of minus 1, here is minus 1, is having one value. Similarly, x of 2 is having value of minus 2. Similarly, x of minus 2 is again having minus 2. But in odd signals you have the opposite. Suppose x of 1, it is equal to 1. Uh, x of minus 1, it is equal to minus 1. They are opposite. See, they are opposite, they are not similar. Then you have x of 2 that is equal to minus 2, whereas x of minus 2 is equal to 2. Or maybe this is when 1 is slightly, see, these values you have to then correlate with the axis and mark the amplitude value, right? Suppose this value is 1 and this is value is slightly lesser than 1, let's suppose 0.78, fine. So x of minus 2 is plus 0.78, whereas x of 2 is minus 0.78, slightly lesser than 1. So they have opposite values, so they are odd signals, right? This is what I have discussed with the help of mathematical interpretation, right? This is the diagrammatic representation. Okay. So whenever in the second lecture or first lecture, I told you that once you supply a signal into a system, you get an output. So this input is called as the input or the excitation, fine. And what you get as the resultant signal, that is the output or the response, fine. This may be a discrete or a continuous, but in DSP we are discussing what? In DSP we are discussing discrete time only, right? So so this your discrete time system is an device or it's an algorithm that performs some prescribed operation on the discrete time signal, fine. Thus the discrete time system has what? An input or excitation and the output or the response. So this is the input or the excitation and the output or the response. So suppose I give an example that yn is the response to the excitation xn. So yn is the input and xn is the, sorry, yn is the output, xn is the input. So how you denote? Yn is equal to t of xn. What do you mean by t? T represents the transformation function. See, when I supply one type of signal, I want another type of signal. That's why I am giving a certain type of signal. Let me give an example. For example, you have a juicer, fine. You add oranges to that, and you want an orange juice, right? So this juicer, what it, see, these are, this xn here are the oranges, and then the juice is the yn. And what happens in the mixer? That is the transformation. So t represents, this is the best example I could give. So t represents the transformation. So xn is the input. When you transform it, you get the yn, fine, or the response. This is the excitation. Clear? Okay. Now you need to understand this folding shifting operation. See, just clearly look at this example. This is your original sequence. Like maybe it's small. This is x of n, this is x of minus n, this is x of minus n plus 2. So what it does, this is your original sequence. This is important for your next lecture. See, so I have, see, on Blackboard I can show you tons of examples. Here I am restricted to, maybe I can show you one or two examples only, because it takes immense amount of time to sort it out in the PPTs and all. But I am trying my best. Hopefully you are getting my point. Okay. Now you have what? Okay, this is your original sequence. Fine. So original sequence is this, at time instant 0 is 0, at time instant 1 it has some value, at time instant 2 it has some value, at time instant 3 and 4, and similarly at negative axis it has also some values. See, here is the amplitude. See, at time instant -1 it has the value of 2, at time instant -2 it has the value of 2. Similarly, here it has the value of, at 4 it has the value of 4, at 3 it has the value. So when I say you just fold this sequence, I give in, see, these things are all done in MATLAB. I give you a signal, I tell you to fold it. So you will fetch some commands into your MATLAB, fine, and you will get a result that will be a folded sequence. So what will be a folded sequence? What happens? So this side will come to this side of the y-axis, and these points, these sample points will come over this side of the y-axis. Fine. So you will have, you just fold it. So you are folding it. So when you are folding it, this 4 will come over this side at starting point. Fine. That is -4. Fine. Then you will have at -3 you will get an amplitude of 3. At -2 you will get an amplitude of 2, and at 1 you will get an amplitude of, at -1 you will get an amplitude of 1. So at 0 you will get 0 only, and then these points will come over this side of the y-axis, and that is, see, 1, 2 and 3. Originally they were here, now they are coming over this. This is folding. Fine. So this is how mathematically shown it. See, it is 2, 2, 2, 0. Fine. Then 1, 2, 3. After it folds, after figure B, it folds it. So you'll get this 4, 3, 2, 1. It starts from this. You are folding it. So this right hand side will come over the left hand side of this. It will be the first tick of the left hand side axis. So we'll have 4, 3, 2, 1, 0, 2, 2 and 2, right? After that, you are then shifting it. What do you mean by shift? See, one is advancing, otherwise delaying. When I mean shift, I am advancing the signal. So by me advancing, I mean, see, by advancing I mean that originally it was starting at -4. Now your signal will start at -2. So the first tick of amplitude 4 will come at -2. Right? So this is x minus n plus 2. Right? So this is folded and shifted. So first you fold it. See, you are given an example. See, you have been told to fold it and shift it and tell me the result. So this is also important in exam, but this is equally important because this gives you the clear idea of what you are doing. So I am telling you that you have to shift now this axis. So shift means advance. So originally your signal was starting at -4. Now you are starting it at -2. So you are shifted it by +2 units. Had it been delayed, so instead of +2, had it been -2, so you'll have, so your shifted sequence would have been this. So now you had to delay it by how many seconds? By 2 seconds. Or it was -4, it would have started at now -6. Sorry, +6. That is, you have delayed your sequence. So don't get see, +2, you have to move it forward. You have to move it in the right hand direction. If it is -2, you have to move it this side, the left hand side direction. You have to delay it. So if it was, suppose -1, so you'll have now -2 or -1, or it was starting at -4. Now it will start at -5. Clear? I hope I'm clear. Now I have also fetched some. This is again the same thing. So folding operation, you have yn, you fold it, you get the x of -n. So what this folding operation is using as fast Fourier transform algorithm. You will understand those operations in the next class, inshallah. In the future class, I hope I will have to. This is very important. FFT and DFT. I hope I will be starting it in real time lecture in university. Otherwise, very difficult to make you understand through PPTs and all. Anyways, okay. So then you have the shifting or advancing operation. So whenever you have advance, you will have plus. Whenever you have delay, you will have minus. Fine. Okay, this is a MATLAB in MATLAB you get results like this. See, when you fold, suppose this sequence, this is your sequence. First I did what I did, I uh, I delayed the sequence. So originally it was starting at -1. When you delay it, so basically it's not here, it's not clear. See, originally it was starting at -1. Fine. Now it is starting at now it is starting at 1. Then you delayed it by 2 sequences. So now it is starting at -4. Fine. So this is the delayed. So you have the original sequence, you delay it. So delay means you move it in the left hand direction, right? And when you have to advance, you move in the sorry, delay means you move in the this side. Fine. Advance, you move in the this side. Okay. Okay. That's all for now. Assalamu alaikum.